and my friend Amin here are going to demonstrate Lab0 for the EC5320 Mechatronics class. This is the first lab, so we will go through all the basics of the ADA system, the Quanzer board, WinCon, and everything else. Okay. So what we have here is this is a hardware-in-the-loop real-time system setting, and so the objective is make a controller in Simulink on this computer. Then the computer sends out digital signals to the Quanzer board, and the Quanzer board has a DA converter which converts the digital signals to analog, outputs it using this wire to a power amplifier. The job of the power amplifier is just to amplify the signals coming from the computer so that it is appropriate enough to drive the motor, because hooking those signals directly would not be sufficient to drive all motors. This motor is a SRV02ET plant. It has, if you can see this, it has the motor is the blue thing right here, and this is the tachometer. That's the encoder right there, and then you have a potentiometer. For most of our experiments we just use the tachometer and the encoder, but in this one we just use the tach, so the encoder is not connected. As you see, the two-load connection on the power module goes to the connection for the motor, because the motor is the load. The tachometer connection goes to either S3 or S4. Note that S1 and S2 are reserved for the part, so do not connect the tachometer there. And once that is connected, there is an important fact that will come up later about this tachometer connection. You also need a wire which goes from here, the 2AD connection on the power module, back to the board, which is here. Please note the order of the pins here, because that can change a lot of things. The yellow one is pin number 1, white is pin number 2, red is pin number 3, and black is pin number 4. All of them need to be connected and in the order mentioned. The thing to note is the pin numbering starts from 1, goes to 4, but on the board the numbering of the channels goes from 0 to 3. So what happens is, when you connect this tachometer input to S4 over here, it will be the 4th pin, but it will be the 3rd channel on the board, and there is a specific setting you need to change, which will be mentioned later. Okay, and to tell you about the objective of Lab0 is we are trying to get the frequency response of the actual system, the motor. And so what we are going to do is basically write some code in MATLAB and make a model in MATLAB, and the code is going to generate sine waves of different frequencies, say 10 frequencies, and we are going to collect data for a particular amplitude for this range of 10 frequencies, and then we put it in a loop, run it again for a different set of amplitudes. So we are going to do about, say, 10 to 15 frequencies for 3 amplitudes. So that should give you like 45 loops or 45 different files of data that you collected from the motor. Once we have that, we process it, and we are going to show you how, and you get the Bode plot, the Nichols plot, and the Nyquist plot from those data that you collected, which basically forms the frequency response of the system. Amin is now going to show you how to make a Simulink model.
Okay. Now I'm going to explain how to build a Simulink block for this lab. First you have to open MATLAB and of course Simulink, and after that you open a blank project. It looks like that, and then we start to build the model. First part, remember that in the lab we have 2 different blocks, 2 different boards. We have different WinCon blocks, so we have Q4 and Q8. So this one is Q4. So in Simulink you go to a Quanser toolbox and open it, and then find the Quanser Q4 series. This one has the analog input and the analog output that we need for this lab, because we have to use the tachometer. We need the analog input and the analog output for this lab. And also for this lab we need a sine wave. It's gonna be the input, and we need scope for the output, to see the output. It's right here. And for the scope we can change the name, put a tachometer, any name you want. And after that we have the block. We can simulate like that, but right now I'm gonna build a clock. The reason with that is because Wincom doesn't stop. We have to tell the board when to stop. Okay, this is the stop simulation. Now I need a constant, and also I need a clock to stop the simulation. And I need, it's right here I guess, a relational operator, and change it and put it in greater. Right. So you make the connections. Like this. If you wanna move it, everything just look pretty. Okay, and right now I'm going to show you, because it's kind of confused sometimes, and the analog output for this simulation is the analog output for the quantum board, this one, and the signal goes to the input of this
Power module.
for the power module. It goes to the motor directly, is the input of the motor. The analog output of the quantum